Hello, my name is Reginald Bennett. Today is the 10th of October. Recording another kind of progress as far as what I'm doing with Unity Arduino and making controller. So again, to refresh you on what I'm trying to do, I'm going to be using Unity inside of a virtual reality simulation, and I want to use the Arduino microprocessor platform in order to create a controller to use with the Microsoft Kinect and with the Oculus Rift. So basically the project currently with Oculus Rift and the Kinect can track my position, forward, backward, left, right. It does some ability to track rotation, but it's not too great. It's mostly just position coordinates in a 3D space. The Oculus Rift will give me immersion as far as rotational looking with for what I'm seeing. But I want to be able to control some things with my hand and also be able to sense what orientation my hand is in right now. So I'm going to go ahead and use the Arduino. What you're seeing on the screen right now is kind of what I'll be leading up to. But here's the chip that I have so far. If you look at what's going on the screen, you'll notice that the boxes rotate at different speeds depending on. So right now you're going to see the right box is rotating because the z-axis of the chip is up. I'll get into all that in a little bit later. But anyway, so I have this hooked up. I'll show you the circuit, the way it's set up. And I got a couple buttons here, which you'll see the LEDs turn on the controller itself. And then also corresponding to the buttons are to things being manipulated on Unity. So first thing that I worked with was just getting I want to get a button and LED combination working, and so for a frame of reference, I only started playing with the Arduino just a few weeks ago, so I'm pretty new to this along with my other classes. So want to get a button working. In here you're going to see I'm using a pull-up resistor concept where there's two leads on the other side of this button like this, and they correspond. So the left leads are the same and the right leads are the same. And so what you do is this push button actually connects those leads when it's pushed down, and they're open when it's not pushed down. So doing a pull-up resistor, we have this green wire going to a digital pin on the Arduino, and so when it's high and the circuit's open, that means that the button's not pressed. And we have that green is in parallel, or is basically connected to the red line on my breadboard. So there's power constantly being fed into the green line, positive 5 volts being fed into the green line when the button's not pressed. Now when I press the button, it completes a circuit between that side and this side, and this is connected to ground. So when it does that, it pulls the input to ground, to 0 volts. So the reason for that is because if you don't do that, you can have some floating values and sometimes get false positives. So it's better in this case to pull the value high when you're not using it with the pull-up resistor to the 5 volt rail, and then pull it down with the ground. Corresponding inside of the Arduino, I then have it do a little bit of logic, very basic logic, to interpret that and then turn the LED on. And the way I have the LED set up is I have digital pin to provide voltage, and so the way the Arduino works is it can provide a certain amount of milliamps at 5 volts, and it's a certain amount per pin and then a certain aggregate. So if you try and use all the digital pins, which there are 13, you're not going to be able to pull out the max milliamperage, but if you're just doing a few pins, you can. And you can look up the spec sheets on that. And so essentially what I'm doing is I'm providing voltage and amperage to this LED by putting the digital lead, that yellow wire, from the digital pin out to the positive part of that polarized LED, and then the negative portion is going to ground. So a real basic circuit there, and then I'll show you the code here in a second. Here's from the other angle. You can see the pull-up resistor here into the input, or the Arduino input. Then what I did was I replicated that and there's another video where I show this, but replicate that for two sides. So my left button is going to be the yellow LED, and the right button is the red LED. And so you can see the wires corresponding just for whatever. The green wire is signal wire for the button, orange wire is signal wire for the right button, and it's just using the same thing. And then these wires up here are essentially just providing ground and power to the ground and high voltage rail on the breadboard, if you're not familiar with those. Here's some testing I did with a vibration motor. And so part of that controller I wanted to make, not only would it sense the rotation and also inputs from button presses, but it's also going to provide you some haptic feedback. And so you can see that right there. That's the thing you're seeing on the screen, and you can see how big it is compared to my phone. However, it does actually have a pretty nice vibration to it. But I'd say about the strength of a cell phone, which, I mean, if you look up these things, that's what they keep saying, and it's legitimate. And you can actually run this just straight off of the amperage and voltage that comes right out of a digital pin without any resistors or anything. There's different. I've only run one at once, but there's different guides and whatnot that say that you should do some transistors in order to pull the voltage from someplace else. But with the minimal testing I did so far, I could do it just basically right into the pin and ground, and it was fine. Even to the point where on the screen you can see here I had the LED plugged into the ground and the signal wire. And so in this case, in this particular circuit, what I was doing was press button was sending positive, letting the Arduino know to send a positive voltage to the green wire, which was then turning on the this and going on. Now next week what I should do is I'll be able to have transmission back and forth. Right now I'm only sending information to Unity. I'm not actually sending anything back to the circuit, but all I gotta do in Unity is just write to the serial port, have the Arduino interpret it, and then I can turn things on and off. But I wanted to get this working today, so that's where I'm at. So this brings us to a circuit that I started working on today in order to calibrate. This is a calibration setup for the ADXL335 3-axis sensor. And interesting to know about this is that I think this is either supposed to be mounted upside down, or you just keep in mind that the direction that these face, which is X to this direction, Y to this direction, and Z going up, those are actually the negative values for those things. So if I turn the chip to face that direction X, that's actually negative, right? So forth. So in this particular calibration setup, they provide you some code online. You can plug into your Arduino and you just get the circuit set up the right way. And you can see I have 3 analog wires going to 3 analog, A0, 1, and 2. Then I have a voltage reference, and then I had just one button, just the white, going over to let me know when I want to calibrate. And so what the calibration stuff was doing was each of these 335 chips is slightly different when they come, so you got to calibrate and find what their values are. And so what you do is you press the button, you rotate this to find the min-max values for the chip, and then once you do that, then for that chip, for that custom chip, what the values to range between, to do the maps and constraints between are. So then I took that and turned it into this circuit, which is what I have in my hands right now, which is a combination of the one you saw before, which is the push button with LED, push button with LED, and the sensor. So that's what we're going to be working with today. Again, this is just a little bit more clean setup, but I showed you before the button with a pull-up resistor to ground, and then LED going to ground and providing voltage here. And then this is just for reference to the picture as far as where I have those wires set up, so you can see them clearly on the board. You see I'm using a Sparkfun red board for Arduino. So let's go back to this, leave it there. Okay, again, so I'm just going to give you another kind of show of how that's working. And so what's happening is right now I'm in the Z positive, and so when I have this straight like this, now you can notice that essentially what I have set up here is X value, Y value, and Z value, and I have all of those going into this one, and then the two little shapes in the back, those are the ones that correspond to my button presses, so you can see when they're working. And so what I'm doing from the Arduino is I'm sending 4 values. I have them separated by commas, and so then I parse those out, read the values, and put them into an array, and then calculate things. So again, the reason the right one is moving because I'm in the positive right now, and so it's positively moving the box that's being controlled by Z. If I rotate it over to its negative Z, you see that it's rotating in the opposite direction. And so let's bring it back. And then if I want to go to just the x-axis, again, and then the y-axis. And then you can see when they all work in concert what happens. And you can see the box up top rotating around. Now this is good for, if I want to continue to turn away, but again, I just want to get this code working. What I actually want to do is have kind of an absolute value for what this is. But I got to do a little bit of math inside of Unity to make that happen. So by next week I should have that, so that it's actually reflecting its current state. So that I want the box to actually be sitting like this until I rotate it, and then do what I need to do as I rotate it. Alright, so that's that. Let's go ahead and turn that off. Let's go into the Arduino script. And it's kind of small, but I don't know how to increase the size in here, so just something I have to deal with right now. But and so down here I have a whole bunch of stuff where I'm describing. Right here in this section is showing that when I did the calibration, I found that the range of values for X was 408 to 622, Y was 400 to 604, and Z was 417 to 630. And then there's some other basic information that comes with it. So then I go ahead and show the axes information here, a more literal translation. Go ahead and setting up the pins here. So I have the button left and right on pins 2 and 4, the LEDs on 3 and 5. I have inputs on A0 through 2, some variables I'm going to be using. I went ahead and input the min-max values for those things, and then also values I'll be using. And then also later on we're actually using this value sample size in order to take 10 readings off of the that chip, the 3-axis chip, the 335. We take 10 readings per value in order to make sure that we get rid of any noise. So we take an average of those values. Basic setup, I'm going to read information off the buttons. Or actually I'm setting up the buttons to be inputs, setting up the LEDs to be outputs, and then letting the analog know that I'm going to be referencing an external device, and then setting the serial up at 9600 baud. Now here I'm going to read the information from the buttons, fairly straightforward. Then calculation for the button value, then I get the axes value, then send it serial to Unity, and then the LED stuff, because that's lowest priority stuff, so just have it last. The button stuff is really basic case statements essentially, which just says, again, if the button's high, which means that pull-up resistor is working, it means the button's not pressed. So if it's high, 5 volts, then the button's not pressed. So it means no press, then return 0. And then I just have simple binary that if the left one is pressed, i.e. it's been pulling down to low, that's 1, send a 1, 2, 3. And then here, go ahead and read the information off of the input. And then I'm going to constrain the values to my min-max values just in case some outlier showed up. And then I'm going to map that range, like I was saying, like 400 to 622, whatever it was. I'm going to map that range to negative 100 so that I have a very easy scale to use inside Unity. Here's where I'm taking the pole size, or the sample size right here, and then just sampling and then dividing by 10. And then here I'm actually outputting the values. So B serial is my button serial value, that 1, 2, 3, or 4, depending on which buttons were pressed. Then deleting here the comma, X value, comma, Y value, comma, and then print line in order to end the line. So that when I read in an entire line, I should get those 4 values all together. And let's see if I can do this without it going crazy. Should be able to. Yeah. So you'll see in here, and if I press the buttons, the first one changes, right? Because that's what I was saying was a B serial. And then as I rotate this thing around, you'll see the different numbers change. So right there, you have -100 on the X value and somewhat neutral on the other two. So that's serial port. Now, when you're doing this, you can't have the serial port and have Unity running at the same time, otherwise they conflict, and whichever one was running first has control of the serial port. So that's the Arduino code. And then we'll go into the admin code here. And I'm just using the standard model develop. And then I found some other samples that I based on this off of. And this is real quick code that I wrote. Setting up game objects that I'm going to reference this and the other, setting up the string, some debugging stuff. But right here is where, alright, so the first thing when you're doing this, you got a system I/O ports, you got to include that. That's not a standard library being referenced by Unity scripts. So you got to enter that in. And then also, if you refer to the other video, there's a setting you have to do as far as its compatibility mode. But in here, I set the serial rate to COM3, and I got that off of the Arduino. Again, any other video, 9600 baud. I'm going to set the off and on values for things, and then here I read in a line. I then take that that array that I instantiated earlier, and I'm going to parse in that string delineated by the commas. So the 4 values would be put into different portions of the array by the comma. And then I'm going to turn the string into int and floats as I need them here. Then down here in spin data is where I take, I'm doing this just to slow down the amount that it's spinning. And then shape X, which is that first shape on the left, that one is I'm having it rotate every update by this amount. And Y, Z, and then just applying it to all of them. So yeah, so that's this particular part of it. Again, go ahead and start that up again, and you can see again that this thing, that the top box there is rotating around it. And then I can do this. And what I'll probably do is, just to make it a little more intuitive, is probably just make the buttons shrink or expand that spinning box. So the next video I'll have, I want to show having the Bluetooth shield working, which I haven't been doing any soldering in quite a while. So I started trying to play with this last week, got some stuff working, but it wouldn't connect to my computer. It's supposed to just automatically, shouldn't have to do too much as part of this shield's advantage. But without soldering the contacts, you get poor connection. And so I think the chip was resetting over and over. So now that I got this aspect working, I'll solder this onto, or at least I'll solder the pins on for a steady connection. And that's just going to make this more of a pain as far as the breadboard aspect of it. But that's all right. And then once I can do that, then I should be able to put the chips and button on top of here, have that stacked on top of the Arduino, and that's something that you can just basically hook to the back of your hand, like with like a like a strap or something like that. That way I can see the rotation of the hand, and then the buttons are going to be the simple mimic of how the fingers are open or closed. So I'll probably just put a button on the thumb at first. But I want to use stuff like flex sensors or some other sensor in order to get whether the hand's open or closed. And then also I got to change the code in Unity so that it's not setting constant rotation values, but rather is actually manipulating the shape and putting it to a specific rotation statically rather than dynamically moving it over and over and over and over. So that's this week. So I got done. And if you have any questions, just email me if you have that, or just post below. Thanks.